These are the frequently asked questions for pre-calculus for section 2.7 day 2, starting with number 31, part A. Suppose that X mils of pure acid are added to 125 milliliters of 60% acid solution. How many milliliters of pure acid must be added to obtain a solution of 83% acid? So here's what we're starting off. We're starting off with 100% of pure acid. And we're going to add the 60% solution. Let me just keep that percent for now. And we have 125 milliliters of that. And we want a concentration of 83% of the mixture. So the pure acid would be 100% as a decimal is 1x. And then we have 60%, and we have 125 milliliters of that. So combined, we would have 83%, and the amount would be X plus the 125 mils that had to be added to that. So for A, it says explain why the concentration C of X of the new mixture is C of X equals X plus 0.6 times 125. And that is divided by X plus 125 because this is the concentration. So if we wanted to solve for 0.83, we would take the left-hand side and we would divide it by X plus 125. And that would give us our 0.83. So they're just manipulating the formula, that's all. So explain why that concentration is C of X equals X plus 0.6 times 125 over X plus 125. My explanation for A would be they have solved for 83% concentration. And that's what the C stands for, is the concentration. And then B says, suppose the viewing window in the figure is used to find a solution to the problem. What is the equation of the horizontal line? Well, taking a look at this, we can see that it's a little higher than 0.8, and we figure out, oh, wait a minute, they're looking for the 0.83, that 83%. So that'll be y equals 0.83. And then C says, what we want to do is write and solve an equation that answers the question of this problem and explain your answer. Well, that's the first one I had up here. That is this equation right here. So X plus 0.60 times 125 equals 0.83 times X plus 125. So we would go ahead and do the math on that one and see what we get. So let's see here, we have 0.6 times 125, so X plus 75 equals 0.83X plus 0.83 times 125, which is 103.75. And then we just combine like terms, etc. So we'd subtract this 0.83X and get 0.17X. We would take 103.75 and subtract the 75, and that would give you 28.75. And we would divide by 0.17. And that would give us 169.118 with rounding there. And that was in milliliters. Now, we're going to explain the answer. The total amount of the solution is X plus 125 milliliters. Of this, the amount of 100% acid is X plus 60% of the original amount. So just explaining there that we have the 100% solution that's being added to 60% of the original amount. In this case, it was 125. But that's how we figure out the concentration and the total of milliliters that would have that concentration over there. So that is number 31. Number 33 is a break-even problem. And it says Midtown Sports Apparel Incorporated has found that it needs to sell golf hats for $2.75 each in order to be competitive. It costs $2.12 to produce each hat, and it has weekly overhead costs of $3,000. In any business, you want to figure out how do you make money, and how they're making money is by charging $2.75 for each one of those golf hats. But they're also spending money, and this is their cost. Their cost is $2.12 for each hat, plus $3,000 for rent, heat, all of that good stuff that comes along with having any business. So 33A says, let X be the number of hats produced each week. Express the average cost, including those overhead costs, of producing one hat as a function of X. All right, so here's what we know. The cost of a hat, we have to take that $2.12 per hat plus $3,000, but since it said average, we have to divide that by the number of hats. We don't know what that is, so that's X. Then they also wanted to know for B, solve algebraically to find the number of golf hats that must be sold each week to make a profit. Support your answer graphically. So for B, what we want to know is when is the cost of each hat? When is that going to be less than $2.75? So when is $3,000 plus $2.12 per hat less than $2.75 per hat? And that, of course, is just algebra. We're going to go ahead and move our x's over to the same side by subtracting 2.12x. That'll give us 0.63x for our 3,000. And then we will divide. And x needs to be greater than 4,761.9. So they need 4,762 hats or more to be sold, and that is hats per week in order for that to happen. So it's all about basically how you make money versus how you are spending your money. And then for C, it says how many golf hats must be sold to make a profit of $1,000 in week 1, and explain your answer. All right, so here's what we know. They're making $2.75 per hat, but we have to subtract those costs. Actually, I'll just keep this as I had it up there before as 2.12x plus 3,000, and we need that to be more than $1,000 per week. So distribute that negative, combine some like terms here. So let's also move that 3,000 over to the other side. And divide. And we will need that to be greater than 6,350 hats per week. So again, it's about taking the 4,000 and dividing that by 0.63, and that comes out to x is greater than 6,349.2. We don't really need the 3 decimal places to know that we're going to have to round that up to 6,350 hats per week. So that's not the first break-even type of problem that we've had. You need to push yourself to figure out that profit comes from making money minus those costs. That's how we always get profit. Number 35, this is a lot like a problem that we did in class. Consider all rectangles that have an area of 182 square feet. Let x be the length of one side. Well, if I'm going to let this be x, I remember that area comes from length times width. So something times x gave me 182, so to work backwards, I can say the other dimension will be 182 over x. And A says express the perimeter. Perimeter of a rectangle is 2 times the length plus 2 times the width. That's going to be 2 times x plus 2 times 182 over x. Well, that makes the perimeter equal to 2x plus 364 over x. So there's our expression. Probably want to make this p of x so that we're using function notation as we go through that. And then B says, find the dimensions of the rectangle that has the least perimeter. What is the least perimeter? So we're going to want to graph this and find that minimum. So let me grab the graphing calculator here and go into y equals. And we need the calculator to graph for us that 2x and then plus parentheses 364 divided by x. Oh, it didn't take my parentheses, did it? Let's try this. I'll just try and insert. There, it took it. All right. We have that, and now we'll go to window. We've talked before about how when you're working with rectangles, generally your mins and your max end up being squares. So we have 182 for the area. We could take the square root of that, or we could sit and think, okay, let's see here. Well, 15 times 15 is 225. I guess I could probably use my area from 0 to 15 for those dimensions. 0 to 15 for length and width. And then we want to see what the perimeter would be as. So we just think about, okay, let's pick bigger than 15. So maybe they're 20. So 2 times 20 is 40. And 2 times 20 would be another 40 for a grand total of 80. And let's see what it gives us. So it looks like I better go out on my x's just a little bit farther so that I can make sure that I'm seeing the graph start to come back up again. So maybe I'll go to 25. And now I definitely can see a minimum. So Blinky ought to be able to find a minimum. Second trace, number 3. And I'm going to get Blinky into position. Again, he has to be going up on the left-hand side. And then we go far enough to the right that Blinky is coming back up on the right-hand side. Take some patience. There we go. And enter through guess. And there it is. We have a minimum at x equals 13.491. And let's see what this was in. This was all in square feet, so that would be feet. And it said find the dimensions of the rectangle that has the least perimeter, so we would need the other one. So we'd take 182 and we'd divide it by 13.491, and no shock here that we get 13.491. It's a square again. So it said find the dimensions of the rectangle that has the least perimeter, 13.491 by 13.491 feet. And what is that least perimeter? Well, that would mean we'd go ahead and plug that in and take 2, well actually 4, times 13.491 just to save a little time because this is a square. And that would be 53.964 feet for the perimeter. All right. So something to remember in the future is usually if you're talking about minimums or maximums with rectangles, that you're going to end up talking about a square. 37 says Drake Cannery will pack peaches in 0.5 liter cylindrical cans. Right away I'm thinking I'm not going to use 0.5 liters, I'm going to use 500 milliliters. Let X be the radius of the can in centimeters. A says express the surface area of the can as a function of X. So things we have to do. First of all, we have to remember that when we're talking about those milliliters, that's volume. And that if it's a cylindrical can, pi r squared h is going to equal that 500. And then surface area, and normally we would use 2 pi r squared plus 2 pi rh, but they wanted us to use an x in this, so 2 pi x squared plus 2 pi xh. And it says express the surface area of the can as a function of x. That means the h can't be there. We have to find something to substitute for h. And the good news is if we divide both sides of our volume formula by pi r squared, we will be able to substitute in for h. We're going to substitute in that 500 over pi r squared. So s of x equals 2 pi x squared plus 2 pi x, and then instead of an r, we're going to use an x because that's what they required, 500 over pi r squared. And then we would go ahead and do a little simplifying. So 2 pi x squared plus, here, an x will cancel out, and we'll have 1x left, and a pi will cancel out, and we'll have 2 times 500, which is 1,000 over x. That is part A. Part B says, find the radius and height of the can if the surface area is 900 square centimeters. So for B, we want to go ahead and put a 900 in here. And various ways that you can solve this. I mean, right now you could punch it in and find the intersection graphically for this one. I guess I would tend to multiply everything by x in order to get rid of the fraction. And then move everything over to one side. And find the zeros, the solutions for that. So, getting that calculator, actually I'm going to move this up so you can kind of keep an eye on that formula while I'm punching this in. And we'll clear out that obnoxious one we just had up there. So we need 2 pi x to the third minus 900x. Didn't take the minus. To be so careful with this smartboard calculator. Just does not like to be good. 2 pi x cubed minus 900x plus 1,000. And pretty obviously we need to think window here. So minimum of 0. And our x is actually the radius of the can. I don't know. Let's maybe go with 15. And what we're really looking here is the surface area, and when we started off, they had 900 as the surface area. So go ahead and punch that in and just see what we need to see. All right, so we have way too many x's here for what we needed. Oh, we don't. Look at that. There's a second one, just like there was in class. I'm going to go ahead and put some negatives in the x, though, so that it's easier for you to see where those zeros are coming from. So we'll know where above and below when we find those. All right, second trace, number 2. Let's see, Blinky is way down. Look at the y values. As I'm hitting the right arrow, we're waiting and hoping to see a positive here pretty soon. There we go. So now we press enter because that is the left of the x-axis. And right arrow a few times to the right and hit enter through guess. And we have 1.121 centimeters. And then the other, second trace, number 2. And we've got to get Blinky all the way back over to the right-hand side. And I remember I put 15 in, so this time I can keep an eye on X and think about, you know, somewhere around 11 and 12 there. All right, so we'll see Blinky soon. There we go. So I want Blinky back under, and I use the left arrow to get him there, and then up with the right, and enter through guess. And we have 11.368 centimeters. All right, back at it because it said find the radius pardon me, and the height of the camp. So we have one radius of 1.121 centimeters and another radius of 11.368 centimeters, and we need the height. The good news is got a great little formula for that. So all we have to do is take 500 and divide it by pi times 1.121 squared. So this comes out to a height of 126.651 centimeters. And then we could hit second enter and just go back and change our 1.121 to 11.368 squared. And that comes out to a height of 1.232 with rounding centimeters. So that was also a good problem, very much like the example that we did in class for number 37. Next up is number 39. 39 says the total electrical resistance R of two resistors connected in parallel with resistances R sub 1 and R sub 2 is given by 1 over R equals 1 over R sub 1 plus 1 over R sub 2. One resistor has a resistance of 2.3 ohms. Let X be the resistance of the second. So 1 over R equals 1 over 2.3 plus 1 over X. That's what they just said to do. You know, make one 2.3 and make the other X. Now, the capital R by itself, that is both of them together at once. So we're not going to substitute in for that. So for part A, it says express the total resistance R as a function of X. That means we want to get R all by itself. So what we would do here for A is multiply each of these terms by our LCD, which is 2.3 XR. Here the R's are going to cancel out and we'll have 2.3X. Here the 2.3's will cancel out and we'll have XR. And here the X's will cancel out and we will have 2.3R. And now what we were supposed to do is get R by itself. So I'm going to factor an R out of the right-hand side to separate that and then divide. So that's why this fits in with this section where we were working with rational functions. 2.3x over x plus 2.3 equals capital R. And then there was a part B. And B says, find the resistance of the second resistor if the total resistance of the pair is 1.7. So that means we're going to go ahead and put a 1.7 here. So 2.3x over x plus 2.3 equals 1.7. And then we're going to solve that. So what I would do is I'd slap a 1 underneath this and do some cross multiplying. So 1.7 times x plus 2.3 equals 2.3x. 1.7x plus 3.91 equals 2.3x. x. Then I would subtract the 1.7x from both sides and divide by 0.6. And I would get 6.517 ohms. Now let's check and see if that was all we had to do for that one. Find the resistance of the second resistor if the total resistance of the pair is 1.7 ohms. That's it, 6.517 ohms. Number 41, swimming pool drainage. Drains A and B are used to empty a swimming pool. Drain A alone can empty the pool in 4.75 hours. Let T be the time it takes for drain B alone to empty the pool. So the first thing I was thinking is, well, we've really done a problem like this before. We've got one pool, and A takes care of that in 4.75 hours. But we don't know about B. I'm just going to use T for that. That's the time it will take for B. So, pardon me. A says, express as a function of T, the part D of the drainage that can be done in 1 hour with both drains open at the same time. All right, so D of T is going to equal whatever we get when we add these two together. To add those two together, we need a common denominator. So this one will need a 4.75 on the top and the bottom, and this one will need a T. So then we will have T plus 4.75 over 4.75 T. That's what we get when we add those together. You just do the math and combine those two fractions. Then, let's see what else we have here. For part B, it says find graphically the time it takes for drain B alone to empty the pool if both drains, when open at the same time, can empty the pool in 2.6 hours. So when this is 2.6, and I actually would just go back to the beginning and say I already have the fact that one drain, one job, one pool takes 4.75 hours for drain A. I don't know about B, but I do know that together that one pool would get drained in 2.6 hours. That's just the easiest way to kind of use prior knowledge for this problem. And then we would go ahead and multiply by the LCD, and the LCD is 12.35 T, because we multiply these two numbers together. 12.35 T, 12.35 T, 12.35 T, and that gives us 4.75 T equals 2.6 T plus 12.35. And we get the T's over to one side. 4.75 T minus 2.6 T is 2.15 T equals 12.35. And, pardon me, we divide to get 5.744H, which stands for hours in this case. It did say find it graphically, so you can verify this on your graphing calculator and make sure everything's going to work here. But I'm just going to do it algebraically for you. And I actually would confirm it graphically instead of confirming it algebraically. I would do it algebraically and confirm that graphically. So I'm not going to waste your time by putting that into the graphing calculator. You guys can do that. Number 55, this is a neat little complex fraction we have going on here. So first thing we need to do is get this to be one fraction. To do that, we want to multiply it by the LCD. And that means every term gets multiplied by the LCD, which would be 1 minus x. Because this is really 1 over 1. So we'll have y equals 1, and then we take a look at what we have. Well, this would be 1 minus x over 1 minus x. That's what we would have here. And then the x minus 1's 1 minus x's, sorry, would cancel there, and that would give me 1. So y equals 1 plus 1 minus x over 2 minus x. Okay, what's next? Well, now we have to put those two fractions together. So that means we need a common denominator, and this is our common denominator. So our little 1, which is really 1 over 1, will get multiplied by 2 minus x on the top and the bottom. Don't lose track of the fact that now we are just adding these two fractions together, so keep that common denominator. 2 plus 1 is 3. Negative x plus negative x is minus 2x. Now, I just went ahead and put it all together, but the directions had actually said what they want us to do is solve this for x. Well, you had to go through and do this first before you could solve for x. But now we want to try and get x alone. So the best way to do that, pardon me, is to cross multiply. And then we would distribute. And now we want to get anything that has an x on one side and anything that doesn't on the other side. And we're going to factor out that x. And then, of course, to get rid of the y minus 2, we're going to divide. So there it is. That is a lot of really good algebra in that problem. And that's a good one to end on.